This is the lab on charging and discharging a capacitor, and that's how it's assembled. Battery, of course. Put a resistor in here, a relatively large resistor, because I need a relatively large time constant to actually measure something, otherwise the experiment is going to be over too quickly. And then here is a capacitor. In my case, I'm using 100,000 ohm resistor. Actually, I better measure that. And it says just to jump a little bit here. Okay, let's make it 96 kilo ohms, 96,000 ohms. While I'm at it, I might as well measure the voltage that I get from the batteries. .18 volts. Then I put capacitor in here. If the capacitor shows something like a minus, I hope this can be seen on the camera, well, it should be connected to the minus part of the circuit. Okay, in my case I'm using a 470 microfarad capacitor. Put a switch in here, keep the switch open, and then I connect. And that's the basic setup, except I don't have a connection here. What I'm going to do here is, this is where I want to measure the current. So I put my current on a max of 200 microamp. I get that from dividing the 3 volts that I have here, roughly 3 volts, by the roughly 100,000 ohms, which puts me around 30 microamps. And then I'm going to plug it in here. And putting my, what is now an ammeter, inside the circuit completes the circuit, except that the switch is, of course, open still. That's the experimental setup for charging the capacitor, and then I turn the switch on. I will show that in my example. Later on, I will show how to discharge the capacitor in my example, but here's the experimental setup. All it takes is disconnect the battery and then connect over here. Again, it discharges through the resistor in order to give it a large time constant. And then I would turn the switch on and it would discharge. But we're going to start out with charging the capacitor.